Hello. Uh, can everyone hear me?
Good evening, sir.
Yeah. Good evening. 1 second. There are one or two people who are still joining. Okay.
Okay, sir.
Um, okay. Yeah, I think whoever is supposed two people are supposed to come, but one student I think is going to watch the videos and not be live today. So I think we'll start. First of all, I want to know something about all of you, like uh, what you need to tell me. You can introduce yourself and tell me something about yourself in the sense that what are you doing, what is your current situation, which exam are you preparing for, because you might be preparing for different exams. Okay, so you can talk to me a few sentences about yourself so that I also know something about you. Yeah, you can go ahead, Sikandar. I think you can go ahead.
Sir, please wait a second. There is an
Yes.
issue with my microphone. I need to resolve it.
I can hear you clearly. Can you listen? Can
Okay,
you?
okay. Yeah. I can listen you.
Okay, so it's
Sir, my name is Sikandar.
yeah.
Um, Currently, I have dropped out from my college. I used to be an architecture student,
Hmm.
but somehow I ended up here, and I have a very good interest in mathematics and
Okay.
statistics.
Okay.
And now I am planning to make my career in mathematics or statistics.
So right now you are in first year of college.
I was in first year of college, but I left completely.
Now you are going to write your CMI, right?
Yeah, ISI, CMI, and maybe I think CUET also
Okay.
for backup in case.
When is the exam for your CMI?
CMI exam is on 19th of May and ISI exam is on 12th of May.
Okay. Okay, fine. So you are probably the only person who is going to write those exams. The other students, I think, are focused mostly on JEE and other normal exams.
Okay, okay.
What about Saurav? Tell me.
Hello, sir. Sir, I'm
Hello.
Saurabh Nayak, sir,
Yeah, yeah.
and sir, I am J2 for S1 2024, sir.
So
And
you are only
now,
preparing for JEE right now, right?
yes, sir. Main focus is only JE, sir. My
JEE
focus.
mains or advanced? What is your main focus?
Hey, sir, both.
Both.
But main focus is only on advanced, sir.
Okay. Right now, have you been doing any test series and all?
Actually, I am doing LN test series and doing PIQs for mains.
So in the test series and all, how are you getting scores? Like roughly, how much are you getting in maths?
In maths, I am getting
Hmm.
45 to 50, sir.
In the mains one?
Yes, sir.
Okay. Fine, fine. We'll try to improve that. So, okay, it's fine. Saurav, then there is Yashwant and
Hi, sir. This
I.
is Yashwant from
Yeah.
class level. I'm currently preparing for JE.
So you are in 11th, huh?
Yes, sir. Like, I
You
gotta complete.
know, so you have learned a little bit of calculus and all, or is it completely new for you?
No. I've learned from like a channel called Mohit Tyagi.
Yeah, yeah.
Yeah, from that.
Hmm. So you are familiar with the basic concepts, no? Because otherwise you'll be doing problems, then you might get stuck.
I have done with the differentiation and application of derivative.
Okay.
Like integration is kind of new for me.
Uh, so fine. So I think we spoke before, and I told you you should start looking at integration, right?
Yeah, I did it.
Okay. So basics of integration, there are a lot of videos on my channel which you can follow. From the beginning, it is taught. So if you understand the basics, then you will be able to follow what is happening. Okay. Uh, so fine. So you are also preparing for JEE. Then there is, I think, Shri, right? Uh,
Good evening, sir.
yeah. Good evening.
Yes, sir, I'm Sheesh. I'm in class 12. I'm preparing for JE right now.
Okay. Okay. And you have you have also been giving your tests and all, right? JEE tests.
Yes, sir. With JE.
Okay. How is it going for you?
So recently, so I could not give few of the exams because
Hmm.
of the reward I was having at school.
Okay, but generally, like in mains, how much is your score roughly in mains and all? Out of 100?
Out of 100 in maths, this time I got 44 in maths. Like,
On average, it is between 40 to 50, roughly.
yes, sir.
Okay. So actually 40 to 50 is a good score only. If you can go up to 60, 65, then that will be a very good score. Okay.
Actually, my chemistry was lagging, so that's why the score was quite low.
Okay. 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 So we will try to improve
Uh,
for everyone who is writing mains this year. Our target will be like get it up to 65, 65 to 70 ideally, but 60 plus is good, is very good score. Because if you get 60 plus in all three subjects, you will get 99 percentile.
Yes, sir.
So 60 in all three subjects means 180 marks. In the last 5 years, 180 marks will give you 99 percentile. Okay. So that should be your goal immediately. So because you have coming up JEE mains in 2 weeks, right?
Yes, sir.
Okay. And the last person, I think
fine.
Skand has also joined, right?
Where is the hand raise option here?
Who is speaking right now?
I'm sorry, sir. Where is the hand raising option, sir? I am not getting it.
Hand raising option. There is a option, I think, in the settings. 1 second. I am not too sure. Recognize hand gestures. Okay. So now try raising your hand and all. There is a chance you can try it out in Zoom, I think. You are not getting it. Hello, can everyone hear me?
Yes, sir. I can hear you.
Okay, okay. So what I would say is during the class, the way we should work is generally you should keep yourself on mute, but if you have to say something, you can unmute yourself. Okay.
Okay, sir.
And ideally, like if somebody else is talking, then don't interrupt them, wait for them to finish, then you can talk. Okay.
Okay, sir.
And the last person is Skand. I think he has not introduced himself. Please unmute yourself for a moment and tell me something about yourself. Skand, can you hear me? Maybe he is not going to talk right now. I don't know.
Sir,
Okay.
I'm in library.
Oh, okay. You are in the library.
Yes, sir.
Okay, fine. Fine. Okay, so what we will do is we'll start with the topic. So basically the idea for the first class is integral calculus, and the basics of integration, I'm sure most of you are familiar with. So I'm not going to cover the theory directly. We are going to learn the theory through problems. Okay. So there is a problem set 26 that all of you might have seen already. That is a good resource. It has slightly difficult problems, like it is mostly at the advanced level and sometimes even higher than that. Okay. So that is a good resource for you to start practicing. I don't know how many of you have already started solving it. I know a couple of you have, but you should
Yes, sir.
start. Yeah, tell me. Is someone saying something? If you're saying something, you can unmute yourself. Otherwise, keep yourself on mute. So what I'm saying is, you should start trying out problem sets on 26. And I hope everyone has that document. I think everyone has the PDF, right?
No, sir.
You don't have it. Why?
Sir, I don't have, sir.
Okay. So I will share it again on the group. Okay. So
Okay.
1 second, on the WhatsApp group, I'll share it right now only because you need to have it. So next class we'll be discussing problems from there. Today's class we will not discuss it because all of you don't have it. Okay. So right now I'm resharing it on the group. Okay.
Okay, sir.
So next class we'll be discussing some problems from this one. So you can download it. It is on the WhatsApp now. Okay. Fine. Today, what we'll begin with is from a little bit of a JEE mains focus. We'll do some PYQs from previous years of JEE mains, and through the PYQs, we'll try and understand techniques of integration. Okay. So I'm going to write down the question. Everybody can try, and then we'll discuss the solution. If somebody gets it quickly, then great. Otherwise, we'll discuss the solution. This is the first one. 0 to infinity 6 by e power 3x plus 6 e power 2x plus 11 e power x plus 6 dx. This is the integration. All of the questions that we'll discuss today will be JEE mains questions. Next class onwards, we'll go to slightly harder ones. So everybody can attempt. If you have any doubt, you can ask questions.
It's all mainly PIQs, na sir?
Yeah, right now this is all JEE mains PYQs, okay? For today's class, it is JEE mains PYQs. From next class, it will be PS26 plus some other problems. Try this question right now. You have roughly 2 to 3 minutes to attempt it. So think of that and attempt it accordingly. What is the approach? Has anybody decided their approach, what to do here?
So can you hear me?
Yeah.
So the denominator can be factorized the e power x plus 1 into e power x plus 2 plus into e power x plus 3, right?
You are factorizing the denominator, right?
Yes, sir.
Correct.
That's
And then what?
the next I think we need to like convert it into a partial fraction type.
Correct. So that is the correct approach. Since you are getting the denominator in this mode, so obviously you should think that if it was written like this, it would have been easier to integrate, right?
Yes, sir.
If it was like the question would have been definitely easier if my integration was just simply this, right? This is an easier integral than the normal, correct? So try to get it into the partial fraction form because that simplifies this. So you have to find out A, B, and C, and then think about what to do next. You can work it out yourself, but what I want to understand is if suppose you have understood the partial fraction, you have figured out the partial fraction, can you do the integration for this directly? Do you have a way to do integration of this? Let's say we have this. How do you integrate this?
Multiplying e power minus x.
Up and down, you can divide by e power minus x, right?
Yes,
or
sir.
multiply by e power minus x, right? What happens because of that? The denominator will start looking like 1 plus e power minus x, and on top you have this, right?
Yes, sir.
And now you can do substitution of this as a variable t, right? Is it clear
Yes.
that substitution method will now work?
Yes, sir.
If you take this as t, the e power minus x dx will become your dt minus dt, and basically this is a very easy integral, right?
Yeah.
I hope everybody is following. If everyone is not, if someone is not understanding something, please tell me, okay? Because if the question is easy and we have got the idea, then we'll not spend too much time on it. We'll move on, okay? I will tell you the
I
answer.
can,
What
can I
was-
directly write, sir? Can I directly write, say, ln mod t, sir? Sorry, ln mod of
Uh-huh.
ex plus 1, because the denominator it is
No.
dx upon x, like.
No, you can't directly write that, no, because this is a dx by this, right? You can't directly write ln ex plus 1 because that means you are taking this as t, right? See, what was the ln thing? 1 by x dx was ln x, no?
Yes.
So if you are taking this as t, then what is dt? dt is e power x dx, right? Saurav, are you hearing me?
Yes, sir, yes, sir, yes.
तो ऊपर में है नहीं ना, d e power x dx है क्या ऊपर में? नहीं है ना?
No, sir, after simplifying, sir, e to the power minus dx multiplied up and down, numerator and denominator.
Of course, after that, so it is done. I thought you were saying directly here you will do that.
No, sir, no, sir.
After doing this, it is over. That part is obvious, no? Everybody will be able to do that, right? What you are saying is correct. Okay. I'm going to tell you the answer. Everyone can simplify it and check if they get this answer or not. But we are going to move on to the next question. This is the answer. Okay. How did I factorize the denominator? Correct. So Skand is asking how to factorize the denominator. So if you have a expression like this, e power 3x plus 6 e power 2x plus 11 e power x plus 6, how do you factorize this? The best way to factorize a cubic is by using factor theorem. Does everyone know factor theorem?
Yes, sir.
So you can say that this is a cubic t cube plus 6t square plus 11t plus 6, where we are saying t is e power x. How did we factorize this? We checked the values of this function of f of t at t is equal to 1, minus 1, 2, minus 2. If you check some values, you will realize that at minus 1, you are getting 0. When you put t is equal to minus 1, you are getting minus 1 plus 6 minus 11 plus 6, which is 0. So minus 1 is a root, therefore t plus 1 is a factor. Similarly, when you check minus 2, you will get t plus 2 is a factor. Okay, fine. So that is the way to factorize, and that is the standard way to factorize such questions. Okay, we'll move on because the question is clear to most of you. The second question is this. I of x is equal to integral of root of x plus 7 by x dx, and I of 9 is equal to 12 plus 7 log e7 if I of 1 is equal to alpha plus 7 log e 1 plus 2 root 2, then alpha power 4 is equal to what? That is the question. So basically you have to figure out I of x. Yashwant, I hope you understood the previous question. Did you get it? Everything? Does anybody have an idea for this? What to do here?
We can multiply by x plus 7 upon the root of x plus 7, right?
You are trying to multiply by the same thing, huh?
Yes, sir. Root x plus 7 up and down, numerator and denominator.
So you will get on top x plus 7 by root of x into x plus 7, right?
Yes, sir. Linear by quadratic form.
Okay, then what will you do?
So then we can write.
Okay. Yeah,
Right.
this is a standard form, right?
Yes, sir.
This is the standard form.
Yes, sir.
So here you will complete this, you will write the numerator as the derivative of the denominator and stuff, right? Plus mu and all.
Yes, sir. 2x plus 7 divided by root of x square plus 7x.
2x.
And we have to multiply half also.
Yeah. So basically you can write x plus 7 as half of 2x plus 7 plus 7 by 2, right?
Yes,
And you can write this as x square plus 7x, right?
yes, sir.
And now you split it into two separate parts, right?
Yes,
The first part is super easy because you can take x square plus 7x as t, right?
yes, sir.
And the second part can be done by the standard method when it is a constant by a quadratic in a root, right?
Yes, sir.
So, okay, this is a nice method. Is everyone else understanding what he has done?
No, sir.
Okay. What are you not understanding? Which step? Tell me.
Like I have done that. I've taken the x square plus 7x as a y, and then I differentiated. I got 2x plus 7.
Correct.
So
So,
after that, how did you make this step?
so listen, here, did you understand this step here?
Yeah.
So now think about it. If I have a linear thing on top and a quadratic thing here, right? Correct.
Yes, sir.
So what I want is the linear thing on top should be written in terms of the derivative of this, right?
Yeah.
That would have been nice, right?
Yes.
So on top I have x plus 7, right? And the
Yeah.
derivative of this was what? 2x plus 7, right?
Yes.
So what I'm saying is, I want to write x plus 7 as in terms of 2x plus 7, right?
Okay.
Basically, the idea is px plus q should be some constant k1 times ax 2ax plus b plus some other constant k2, right? Do you understand what I'm saying right now?
Yes, sir.
Right? Take the derivative of this denominator, multiply it with some constant plus some constant. You can find k1 and k2 such that this becomes px plus q, right?
Yes.
What I'm doing here is the same thing. See, half times this plus 7 by 2 is equal to x plus 7.
Sir, but again we can distribute it, right? Like half 2x plus 7 by square root of that.
Correct.
Plus
Again, we will
7 by-
distribute it, but yes, again, we'll distribute it. What I will say is we'll separate it out into two separate ones, right?
Yeah, yes, sir. Yes, that's what I'm saying.
So that is correct. What is the doubt then?
Then how can I find now this one?
Which one? First one is easy, right?
Yeah, second, yeah.
First one is easy, no?
Yes, sir.
Second one is what you are saying is a doubt, right?
Yeah. After doing this all stuff, and that will be hard.
That is not hard at all. That is a standard integral. So for example, 7 by 2 by root over x square plus 7x you have to do, right? So 7 by 2 is a common outside, right?
Yes,
It is
sir.
dx by root over x square plus 7x. What do you do here? You try to complete the square, okay? So
Okay.
to complete the square, you have to add a 49 by 4 and subtract a 49 by 4, right?
Yes, sir.
Correct, no?
Yeah.
So now it is becoming a formula, no? X plus 7 by 2 whole square minus 7 by 2 whole square, right?
Yeah.
Inside the root, if you have an integral like this, root over x square minus a square, you should know how to do this.
Yeah. X, we can take x plus a, x minus a.
No, this one is done by, this one has a direct formula, log of x plus root over x square minus a square, right?
Yeah.
Is everyone aware of these standard integrals like this one? सबको आता है ये?
Yes, sir. Yes.
So the general method for this is knowing that x is equal to a sec theta will help us solve it. Okay. Why? When you do x is equal to a sec theta on top, what will happen? A sec theta tan theta d theta, right? And denominator will become a tan theta.
Yes, sir.
Is everyone understanding what I'm doing?
Yes, sir.
Sir,
Huh.
I think I need to brush up some basics.
Yes.
I am feeling nostalgic in this class because I studied
Huh.
this in way back in 12th class. So
But
I know what this thing is, but I'm not able to recall properly.
so what you have to do is go back to integrals, because integrals is definitely part of your syllabus. Okay.
Yeah.
So what you need to do is go to the channel, revise. There is not a lot, but there is 10-15 videos in a playlist in calculus. Okay.
Yeah.
If you do 1 week of effort, you will recall all of it. Okay.
Okay, sir.
2-3 videos you have to watch completely
Yeah.
and follow it.
But
Okay?
I know this thing, that standard forms and all, na, but I'm
Ah.
not able to recall properly.
That's fine, but you need to put in a little bit of work. Integrals
Okay, sir.
is part of your syllabus. You need to do it. Okay.
Yes, sir, I will.
Anyway, for the others, notice that this becomes sec theta tan d theta, right?
Yes, sir.
And the integral is ln sec theta plus tan theta, the integral of sec theta. Okay.
Yeah.
When you put it back, when you put sec theta is x by a and tan theta becomes root over x square by a square minus 1, then you will get the formula that I just now used. Log of x plus root over x square minus a square. Okay.
Okay. Like
So the
we have to use all the properties.
properties nahi, ye standard integral this is. Okay. By the way, there is another method, although the method that you have used is quite nice. Who was the person who started this method? I think it was Yashwant. Who was the person who gave this idea?
Please.
I just asked out.
What?
I just asked you the doubt.
No, I know that, but the person who gave the method, multiply by root of x plus 7.
Use the method, please.
Okay. So there is another method also, by the way. The other method is, if you don't know how to do that, what you do is just try to remove the roots. Okay. How do we try to remove the roots if we have no other good ideas? What is the easiest way to remove the roots?
Take half power.
Take x plus 7 by x as t square, right?
Yeah.
Squaring.
Correct. So basically, we are just changing the variable and calling this as t square, correct?
Yes.
So 1 plus 7 by x is t square. If you differentiate this, it will become minus 7 by x square dx is equal to 2t dt, right?
Yes, sir.
Okay. So now what is happening here? When I put it back here, it will become t, and for dx, I have to write 2t dt by, for dx, I have to write my minus 7, and I have to multiply by x square, right? Somehow, right?
Yeah.
So for x square, I'll have to solve a little bit here, because I will solve from here. I will say t square minus 1 is 7 by x. So x is 7 by t square minus 1, right? So
Yeah.
x square will be 49 by t square minus 1 whole square, right?
Yes, sir.
So it will become 49 by t square minus 1 whole square. and this 7 and all will get cancelled. You will have minus 14 integral of t square by t square minus 1 whole square, right? Correct?
Yes, sir.
So this is a method for people who couldn't think of rationalizing the thing like we did earlier. So this can be solved. This is not so hard. Okay. So think about it. How would you solve this integral? Integral minus 14 t square by t square minus 1 whole square dt, right?
We can write in numerator +1 and -1.
That
Then
is
divide.
one way to do it. Yes. No, but the problem that will happen is the one integral will be simple. The other integral will be annoying. I think, maybe. Wait, 1 second. I think it is correct what you said. I think it will be fine, both of them.
Yes,
For
sir,
example,
because the squaring part will be in denominator. Yes.
ऐसा हो जाएगा ना, और फिर एक तो simple है,
Yes, sir.
दूसरा वाला is a little weird, right? This one will become a
दूसरे
little
वाले
weirder. Correct?
दूसरे वाले को स्क्वायरिंग में है.
Easy way to do it, I will tell you. Easy way to do it is divide by t square up and down. Okay. What will happen? See, if you divide by t square, there will be 1 on top, and here it will become t minus 1 by t whole square. Is everyone following?
Yes, sir. Yes, sir.
Right? So now it will become dt by t square plus 1 by t square minus 2, right?
Yes, sir.
Okay. This is also a little annoying only.
This part when t square -1.
Now what you can do here is similar to what Saurav was saying earlier. I think what you can do here is 1 plus 1 by t square minus 1 by t square. And keep this as t square plus 1 by t square minus 2. So what is the point of doing this? We can split the integral into two parts, right? We can say 1 minus 1 by t square divided by, we have t square plus 1 by t square minus 2, and the other part is
1 by t square.
no, that is going to not work. It is a little tricky. Okay, I'll tell you what will work here. This is not going to work because it will run into the same problem here, the problem that we had in the first one. Okay. But what will work is something like this. This is a nice trick. See, here in this place, I will do half and I will write it as 2. Okay. What is the point of doing that? The point of doing that is now 2 I can split like this. 1 plus 1 by t square plus 1 minus 1 by t square, right?
Yes, sir.
And now it is nice.
Okay.
Now it is nice because see, here I will take t minus 1 by t as z, and that will be solved directly. Do you understand? If I take t minus 1 by t as z, 1 plus 1 by
Yeah,
t.
yeah, yes, sir. If we use the
Correct.
integration by parts.
Correct. No, not integration by parts, just substitution. Take
Yeah.
t minus 1 by t as z. What is the derivative? 1 plus 1 by t square dt is dz, right?
Yeah, correct.
So dz by z square आ रहा है ना?
Yes, sir.
Here,
डिनोमिनेटर का जो है सर ऊपर में भी वो आ जाएगा. हाँ. Yes.
here what I will do is instead of this t minus 1 by t square, I will write it as t plus 1 by t whole square minus 4. Right?
Okay, sir.
Why am I doing this? Because here I need 1 minus 1 by t square, right?
Yeah.
So the substitution must be t plus 1 by t is z, right?
Yes.
Is everyone following how we are doing it? There is a slight complication in this. There is a trick here. The trick is converting the 1 into 2. Hopefully you guys are understanding what I'm saying.
Yes, sir. I'm understanding it.
Okay. Is everyone else also following? The first method is also fine. The second method I'm showing you here. Okay. Now you should be able to solve the integral. So therefore now you should try the original problem and find the answer. Maybe Shrees has already found the answer by now.
I was trying the other method of factorizing that t square thing.
Okay. Okay, fine. So now we'll go back to the original problem. We have two methods to solve it. The second method, the one that I showed just now, and the original method that you had found, okay? And we have been given some data. I of 9 is equal to 12 plus 7 log E7, and I of 1 is equal to alpha plus 7 log E1 plus 2 root 2. And you have to find alpha power 4. So you should try and work out the solution yourself, but for now I will tell you the answer here. You can check it later. We'll not spend too much time doing the simplification. The answer is this. ln x plus, 1 second. So I'm not sure the answer will come in a nice and simple way. So the answer should come in terms of t, and in terms of t, the answer is coming like this: -7 1 by 4 ln t plus 1 by t minus 2 divided by t plus 1 by t plus 2 minus 1 by t minus 1 by t plus c. This is in terms of t. And what did we take as t? We took x plus 7 by x as t square.
Yes, sir.
So if I want I of 9, I have to put 9 here, right? 9 plus 7 by 9 is t square, right? So this is 16 by 9. So t must be 4 by 3, right?
Yeah.
So when you put 4 by 3 in this, you will get the value of I of 9. Okay. Correct?
Yes, sir.
And from there, you should be able to find the integration constant c, right? Because I of 9 value was given, right?
Okay. Yes, sir. I understood it.
And for t is equal to 1, what has to happen? You need I of 1 here. So when x is 1, you get 8 by 1. So t square is 8. So t is equal to 2 root 2 in that case, right? So if you put t is equal to 2 root 2, you should get I of 1, right?
So that means we have to find the constant, right?
Constant 9 वाले से आ जाएगा constant, right? From here. When you put t is equal to 4 by 3, you should get x should be 9, right?
Yeah.
Is everyone understanding? From this substitution, I am saying that, okay? When x is 9, you are getting t is 4 by 3, right?
Yes, sir.
And if you put t is 4 by 3 in my integral in the form of t, you should get the value of the integral, and then constant can be evaluated because we know the value, right? Correct?
Sir.
And then again do the same thing, but this time you have to do x is equal to 1. So when you do x is equal to 1, your value of t becomes 2 root 2, right?
Yeah, and yes, sir.
And now you already know the constant, so you should be able to find alpha then. Correct?
Yes, sir.
It is a long question. If it comes in the exam in JEE Mains, the best strategy for this question is to skip the question, because this is too much time it will take, right? Basically, the answer is alpha will come out to be 2 root 2 and alpha power 4 will come out to be 64. But this takes a little bit of time. I don't think you can do it in the exam. This is too long for the exam. Obviously, you need to realize that in the JEE mains paper, you have 25 or 30 questions actually, out of which you have to do 25, right? Correct?
Yes, sir.
25 questions in 1 hour, you need 60 plus marks. So you need to do around 15 questions correctly. So obviously you can skip some of them. In the exam, you have to decide wisely which ones to skip and which ones to do. So that is the thing that you will get by practice. Okay. So the idea of when to decide, when to skip, when to not skip. So this is a question which is long. You should know how to do it, but in the exam, probably you will not have the time. Anyway, we'll move on. Let's look at this one. I of x is integral of e power sine square x cos x sine 2x minus sine x dx. And we are given I of 0 is 1, and we have to find I of pi by 3. Okay, try this one.
Sir, it is half e to the power 3 by 4.
How are you getting the answer so fast? Please share with everyone.
Sir, it's like a simple formula, right? It's like a method.
This method,
Yeah, yeah.
this formula everyone knows.
It was in your lecture number 1, I guess.
Yeah, it will be in my lecture, but does everyone know the formula?
Yes, sir.
How does it come? Does everyone know how it comes?
So we can differentiate e power x into f of x, then we get the same thing.
Yeah, you have
Ah.
proved that. Proved that.
That is by differentiation, but suppose you didn't guess this, then by direct proof also you can get, no, by parts.
Yes, sir, by cancellation.
Integration by parts, if you do of this one or if you do of this one, you will be able to cancel the other one, right?
Yes, sir.
Correct. So, but the problem here is that here you have sine square x, no?
Yeah, it can be also differentiated, right? The like I got the formula from the Google that if e to the power f of x is given, so it is also differentiated. If e dash f of x into g dash g of x minus g dash x.
E dash,
No,
wait,
f dash x
hmm,
g of x minus g dash x.
g of x minus g dash x. No, what are you saying right now? You have learned a new formula for e of f of x case. You are saying, that is what you are saying?
Yeah, yeah.
So, see, no need to remember multiple formulas, but what I'm saying is, the way to do it is, the formula for us is when x was a variable and this was a function of x and f dash x, right?
Okay,
Correct?
yeah.
So you don't have to memorize the formulas. You have to realize that, okay, e power sine square x is here, and I need to make sine square x as my t or something, no?
Yes, sir.
Then only it will become e power t like this, right?
Yeah.
So if I take sine square x as t, I will get 2 sine x cos x dx as dt, right?
Yeah.
Correct. So basically I get sine 2x dx as dt, right?
Yes, sir.
Correct. So I can take sine 2x common from here, no, outside. So I get cos x minus sine x by sine 2x, correct?
Yes.
Correct, no? Is everyone understanding what I'm saying? So now you can say this is e power t and sine 2x dx becomes a dt, and you just have to write this stuff in terms of t, right? Correct?
Yes, sir.
So cos t मेरा क्या है? T is sine square x, right? So I need to write cos x in terms of sine square x. So obviously 1 minus t will be cos square x. So cos x is root 1 minus t, right? Correct?
Yes, sir.
Yes, sir.
And can you see that sine x by sine 2x is 1 by 2 cos x? So this is just minus 1 by 2 root over 1 minus t.
Yes, sir.
So now you have got it in the required form, no? E power t f of t plus 1 plus f dash t. Correct?
Yes, sir.
So the answer is e power t f of t. This is my answer. And now you put back the e power sine square x cos x.
Will come by parts.
क्या? It will come by parts. What will come by parts?
The formula, the proof of the formula which you have
The
written.
proof of the formula comes
upwards.
by parts, because you can say e power x f of x plus e power x f dash x integral separately I am doing, okay? Let's
Yes,
do
sir.
the second integral by parts, okay? So I know integral of f dash x is f of x, right?
Yeah.
Yes, sir. Yes, sir.
Take that as the second function, take e power x as the first function. So first function is not
Yes.
integrated, second function is integrated, minus first function is differentiated and second function is kept as it is, right?
Yes, sir.
तो देखो वो कैंसिल हो गया ना e power x f of x आगे वाला.
हाँ हो गया सर, अब बीच वाला रहेगा, ठीक है सर.
Okay, so that is an easy question. This one is easy only. Let's go to the next one. Okay, this next one is this: I of x is equal to integral of x plus 1 by x 1 plus x e power x whole square dx. This is a pretty standard integral. You might have seen it before. You have to find out limit of x tends to infinity I of x. It is given that if this is 0, then what is I of 1? This type of integral you might have seen in your practice. This is a common integral. Or at least it looks familiar to me. I don't know about you guys.
We have to write 1 plus x e to the power x as t, sir.
Correct. That is correct idea.
Yes, sir. And we get x. Sorry, yeah. If we do differentiation, we get ex common and 1 plus x.
Dx is equal to dt, right?
Yeah.
So then when you put it there, you will get x plus 1 dx will become dt by e power x. And there is a x here and there is a t square here, and x e power x can be written as t minus 1, right? So it is becoming like this.
Yes, sir.
I hope everyone is understanding how we are getting it to this, right?
Yes.
Okay, so once it has
Yes, sir.
become like this, then you can do intelligent things to the numerator to try to simplify it. The best thing to do would be subtract t square, add t square. Because what will happen with that? When you split it, it will become simple, right? 1 minus t square by t square into t minus 1 plus 1 by t minus 1. Correct?
Yes, sir.
And this will get cancelled with a minus of t plus 1, right? So you are getting minus of t plus 1 by t square plus 1 by t minus 1. And now you can split it further and each term is simple integration, right? You are getting minus 1 by t minus 1 by t square plus 1 by t minus 1, right?
Yes, sir.
Is it obvious to everyone what we have done so far here?
Yes, sir. But how we gonna integrate 1 by t minus 1?
कोई भी issue नहीं है. T minus 1 is z. dt is dz. It is ln t minus 1.
हाँ.
मतलब सर z के अंदर e to the power x का कोई टर्म रह सकता है क्या?
z के अंदर e power x का अभी x में तो है ही नहीं ना, अभी तो पूरा t में आ गया है ना.
Okay, okay. We have to take in terms of t only everything. Like
No, right now everything is in t, right?
yeah.
Our first job is to find the answer in terms of t. Then we'll put back the x and all, right?
Okay, I get it. I had a little confusion.
So right now, if your integral is this, there is no issue, no, in this.
Yes, I got it.
Then later, once you have gotten the answer for the integrals of this, you will start putting the x stuff back, right?
Yeah.
Correct?
Yes, sir.
I hope it is clear for everyone. It should be obvious, I think, this one.
It is a standard problem, no, sir.
Kya? What are you saying?
Yes, sir. It is a standard problem, sir.
Yeah. Okay. So this is clear. One question that I wanted to discuss was, I think Skand had asked me this question today. This is question number 102 in the problem set. Okay. Question 102 in the problem set 26. So the question is actually quite difficult. I will not show the whole thing, but the question looks scary and it looks like this. This is the question. You can check it out in the document that I have shared. The other people who have not seen it. So this is the question divided by 1 minus cos 2x. This is a question from Harvard MIT integration competition. Okay, so it's a nice question, but right now it looks a little scary, right?
Yeah. Sir, can we take common something?
So the point is to think of what should be taken common. The numerator, obviously you have to simplify it a little bit, right? ऐसा इंटीग्रेशन तो कर नहीं सकते हो, इसको पहले सिंप्लीफाई करना पड़ेगा, right?
Yes, sir.
So obviously, what groupings do you think you should take?
So we can split 2 cos 2022x as in two terms, like minus cos, and we can group one with this one 2021 thing, and another one with 2023. Right?
That is one way to do it, but what I would say better is group this term and this term, right?
Sir, can we use the formula cos C plus cos D?
Which formula? Cos?
Cos C plus
Exactly. Cos C plus cos D. वही करना है. So what I'm saying is, it is obvious that these odd terms can be grouped nicely, right? It will come nicely, right? So
Yeah.
what you should do is 2 cos x. You keep it as it is. Plus 2, keep it as it is. Keep the middle term as it is. Right now, don't touch it. But do minus of cos 2021x plus cos 2023x, right? Correct?
Okay, yes, sir.
Cos c plus cos t यहाँ करोगे तो क्या आएगा? It will become 2 cos x cos 2022x.
Yes, sir.
Right?
Yes.
And now see what is the benefit. We can take cos 2020x common, right? 2022.
Yep.
So we'll take this common, cos 2022x common. It will be 1 plus cos x. And see here also 2 times 1 plus cos x, right?
Yeah.
So the whole thing gets nicely factorized and becomes 1 plus cos x common and 2 minus, so 2 common, 1 minus cos 2022x, right? Correct?
Yes, sir.
This is the numerator, okay? And now we look at the integration more seriously. So the integration has become like this. 2, 1 plus cos x and 1 minus cos 2022x divided by 1 minus cos 2x. Right? Correct. So at this stage, it is useful for us if we change the limit of the integral. Skand, if you are hearing this, you were doing mostly this type of thing also in your solution only, but it will be better if you shift the limit of the integration to make it look like this. Instead of using limit 0 to pi, it is better to do it in minus pi by 2 to pi by 2. Okay. The reason it is better is you know properties of even and odd functions, right? If it was an odd function, what is the value of integral minus a to a of an odd function?
0.
0, right? And if it was an even function, minus a to a, even function will be twice of 0 to a, right? Correct?
Yes, sir.
So since those properties are nice, it is more convenient for us to change the limit of integration from 0 to pi to this limit.
सर नीचे
Maybe
cos 2x है
नीचे 1 minus cos 2x है, right?
सर मैंने cos square x लिख लिया था
ओ, तुमने देखा नहीं था क्या सही क्वेश्चन?
लगता है गलती उतार लिया
हाँ, तो अगर वो किए होगे तो फिर थोड़ा गलत हो जाएगा, लेकिन द आइडिया इज you should try to think of utilizing this minus pi by 2 to pi by 2 limits. Okay, so how do we do this change? Does anybody know what to do to make this change like this?
So we can add pi by 2 to the x.
You can say x is equal to pi by 2 minus t, right?
Yes, sir.
If you do this change, the new integral will come in terms of t and the limits will change, right? Correct?
Yes, sir.
So the limits will change like this. When x is 0, t will be equal to pi by 2, right? And when x is pi, t will be equal to minus pi by 2, right? Correct?
Yes, sir.
And the integral will change like this, 2 times 1 plus cos of this. Cos of this will become 1 plus sine of t, right? And 1 minus cos of 2022 pi by 2 minus t. We have to check that out. Dx will become minus dt, right? Divided by 1 minus cos of 2 times x is pi minus 2t. So this is pi minus 2t. Notice that we have nice identities for that, and it will come out in a slightly simple form only, not very complicated. So what I'm doing is I'm shifting the integration. The minus sign will come here and reverse the limits, right? Do you understand what I'm saying?
Yes, sir.
This minus sign will change the limits of the integration from pi minus pi by 2 to pi by 2. And inside I will have 2 times 1 plus sine t multiplied by, notice this, what will happen here? 1011 pi minus 2022 t. And this is an odd multiple of pi, and you have to take a cos of pi minus this. So that will be minus cos 2022 t, right? Is everyone following what is happening here?
Yes, sir.
So you will get a 1 this part becomes minus cos, so it becomes 1 plus cos 2022 t, right? Divided by this part will become 1 plus cos 2t again. Correct?
Yes, sir.
I hope this till here it is clear for everyone what we have done.
Sir, can we not simplify the given expression further? Like,
This one
yeah.
you can, but the problem will be what to do about this later. This one can be written as 2 sine square x, for example, right? But उसके बाद अटक जाओगे, उसके बाद फिर I don't know what to do after a point. You can simplify it. You can try it out. Maybe there is a solution by that method also, but I am not aware of it. I have not tried that. Okay.
Okay, sir.
So you should
Like-
try it out and see if it works. But what I'm saying is this is what has come so far for me. Okay. Now
Yeah.
you will see the benefit of why we changed the limits now, because what I will do is I will multiply 1 plus cos 2022 t and expand the numerator into 2 parts. Okay. So let's do that. So we'll say 2 times 1 plus cos 2022 t plus 2 sine t 1 plus cos 2022 t, and the denominator is the same, 1 plus cos 2t and 1 plus cos 2t, right? Isn't this the same integral? What have I done? I've just split it into 2 parts, right? I hope everybody is understanding what I have done.
Yes, sir.
Because this is 2 plus 2 sine t, no? So multiply this with this and write it like this, split it apart, right?
So the second part becomes 0.
Correct. Second part is an odd function. That's why we changed the limits. The second integral is directly 0. See why it is an odd function. This is even, but this is odd, right?
Yes, sir.
Do you understand the benefit of switching the limits? So now my integral is only this much, right? Is it clear to everyone what we have done?
Yes.
Okay, so at this point, I have a limit of minus pi by 2 to pi by 2, and I have 2 times 2 comes out. You have 1 plus cos 2022t divided by 1 plus cos 2t dt. I am not going to show the remaining steps right now. I want you guys to try it, okay, and think about it. But what I am going to tell you is a simple hint that will be used in the problem, okay? So what is the hint? This is an identity that everyone should know. The identity that I want to share is this one: sine of n plus half x by sine of x by 2 is equal to 1 plus twice of sum goes from k1 to n cos kx. This is known as Dirichlet's identity. It is involved in some higher maths. You have to do this in Fourier series and all, but the proof of this is pretty simple. Has anybody seen this identity before?
No, sir. Sir, I have a doubt.
Uh,
So can we use Taylor's theorem?
what theorem?
Like sin x can be written as x minus x cubed by 3 factorial plus x to the power 5 by 5 factorial.
Sin x. Oh, Taylor's theorem.
Yeah.
Taylor's theorem you will not be able to use here because, like, see, integration, while you are doing integration and you try to do Taylor's theorem on the top and bottom, it will not work out very well for you because it is difficult to manipulate the infinite series, right? How will you do it, right?
We can take the first 2 or 3, then try.
हो नहीं पाएगा ना, क्योंकि डिनोमिनेटर में भी तो सीरीज है ना, कैसे करोगे? तुम समझ रहे हो क्या हो रहा है प्रॉब्लम?
Yes, sir.
The numerator has a series, great. If it was only numerator and you have to integrate, what you are saying is fine, and you can take the first few and get a rough answer, right?
Yeah.
But do you know how to divide two infinite series? How will you do it? There's no chance, no?
We
Matlab-
cannot. But sir, if it is infinity, if x is infinity, then we can take it, right?
If x is?
X is infinity, like x is approaching to 0 or infinity, we can do 1 by infinity form, bring it.
What you are saying is limit. You are saying you are saying I will take a limit, right?
No, sir. Like I'm saying, like if we bring a form 1 by infinity, 1 by infinity, then it will be 0, right?
Correct. It will be 0 and all. But what you are saying to me sounds like you are trying to take a limit, right?
You cannot take the thing in integration.
No, you can't. How will you do it? See, for example, let's say you have this situation: sine 3x by sine x, right? What you are saying is, I will expand this by Taylor series, and I will say 3x minus 3x whole cube by 3 factorial, and so on, 3x whole power 5 by 5 factorial. But denominator is x minus x cube by 3 factor. What will you do now? Like, there is no nice way to simplify this, no?
Yeah.
The problem is the denominator. There's no way to simplify it nicely. We don't know how to divide two infinite series from each other. If it was just sine 3x, you could have removed this then if you calculate the integration here, do term by term integration, the answer that you will get will approach the actual answer. Okay.
Okay, sir.
But you can't divide and then do the integration. That's not possible. How do you divide it? I don't know how to divide also.
Like
Right.
in limits, I used to do it like we take x common and we just divide.
You take x common and then what?
Like in limits, we had like
हाँ,
I used
limits
to.
में हो सकता है, limits में तो हो ही सकता है, but this is an integral, no?
Yeah, I get it. I get it.
So that is a problem. So what I want you to realize is, I'm not going to show the next steps here. You should try the next steps yourself. But this identity you need to prove, and you need to learn this identity, because this will come in handy many times for you. Okay. So I will prove the identity. So you have sine of n plus half x by sine of x by 2. And I want to show that it is equal to 1 plus 2 summation k goes from 1 to n cos kx. Now, let's say that this part is called f of x. F of x is 1 plus summation twice k goes from 1 to n cos kx. Okay. Now, the way to do the proof here is do a telescoping series method. Everybody has heard of telescoping series, right?
Yes, yes.
No.
So, telescoping series is when you try to do the sum of, how do you do the sum of this series? Do you know how?
No, sir.
The way to do it is split each term so that it is a difference of two terms. So for example, you'll say 1 by 1 into 2 can be written as 2 minus 1 by 1 into 2, right?
Yeah.
So this will become what? 2 by 1 into 2 minus 1 by 1 into 2, right?
Yeah. We can do for the same 3 also, right? 3 minus 2 by
Exactly.
2 into 3.
Exactly. What is the benefit? Because it will become 3 by 2 into 3 minus 2 by 2 into 3. And notice that this is 1 by 2 and this is 1 by 3. And here also minus 1 by 2 was there, no?
Yeah, we can just split it into fractions.
We are splitting each term in the difference of two terms, and the terms keep getting cancelled, by the way. Do you realize that the terms will keep getting cancelled? The first term is becoming 1 minus half. Second term will be half minus 1 by 3. Third term will be 1 by 3 minus 1 by 4. Can you see what is happening?
Yeah.
The terms are getting cancelled, and you will have first part of first term and last part of last term will remain, right?
Yes, sir.
That method is called telescoping series. By the same method, we are going to solve this one. So in order to do that, what you need to do is multiply both sides by sine of x by 2. Multiply f of x by sine of x by 2. So what will happen? Here it will be sine of x by 2 plus, take the 2 inside and write it like this. K is equal to 1 to n 2 sine of x by 2 cos of kx. Okay. Can you use the trigonometric identities to split this as a difference of two sines?
Sir, you're saying the formula?
The formula. Do you know the formula which splits this into a difference of two sines?
The sine of a plus b
I
plus sine of a minus
into
b.
sine of a minus b.
Sine of a plus b minus sine of a minus b, right? Correct? Where a is x by 2 and b is kx, right?
Yes, sir.
So this can be written now as sine of a plus b becomes k plus half x minus sine of a minus b becomes a minus b. I hope it comes like this. Just check it once. I hope it should come like this, the whole thing. Check the value of this. This should come equal to this.
Happens in plus case, I guess.
When you do sine c minus sine d, what will happen? 2 sine c minus d by 2. C minus d will become x by 2, correct? Cos c plus d, it is correct. What I have written here is correct. This is equal to this. Everyone convince yourself that it is correct.
So a minus b should be 1 minus 1 by 2 minus k into x.
This part is wrong. I think the use of the terms A and B is wrong. But finally, this is coming. This is right.
Yes, sir. That's right.
Is everyone sure that this is equal to this? Sure, no?
So it will be k by 2, right?
No, it is k plus half into x and k minus half into x. Because when you add the two angles, what is coming? 2kx by 2.
Yeah, I get it.
And when you subtract, it becomes x by 2, right?
Yes, sir.
So because it is coming like this, now notice what happens when you put k is equal to 1. It will become sine of 3x by 2 minus sine of x by 2, right? When k is equal to 2, what happens? Sine of 5x by 2 minus sine of 3x by 2.
Yeah.
Can you see that the pattern is cancelling? The telescoping series thing is happening,
Yes, sir.
right? So think about it. When you go till n terms, only the first part of the n term will be remaining, no? Sine of n plus half x minus sine of n minus half x. The n minus half x will get cancelled, right?
Yeah.
And what will be left? This part will be left, no? After doing the telescoping series here, right?
Yeah.
And the first part of the first term, second part of the first term will be left, this part, right?
Exactly.
So what you will get is what? Sine of n plus half x minus sine of x by 2 after doing the summation, correct?
Yes, sir.
And notice that this gets cancelled with this, and you are getting fx into sine x by 2 is equal to this, right?
Yes, sir. I understood it.
So fx is what? Sine of n plus half x by sine of x by 2. So we have proved the identity, okay? Are you understanding the proof is done?
Yes, sir.
So why am I telling you this? Because many times you will see some tough integrals you might come across. You should always try to use this identity. Whenever you have a ratio of signs, right? Notice that if you take x by 2 as t, so basically x is equal to 2t if you take. What kind of integrals are it? What kind of situation will happen? You will get 2t you will put here. So it will be 2n plus 1 into t by sine of t, right? So what is happening? It is sine of 3t by sine t, sine of 5t by sine t, sine of 19t by sine t, right?
Yes, sir.
Anytime you get a fraction involving odd sign by sign, right? You should think of this, because this will convert it directly into a sum of some causes and all, right?
Yeah.
That is much easier to integrate. Which side is easier to integrate, you think? The
Right
right
hand.
hand side. Right hand side is much easier to integrate, okay? So in the problem that we have seen, problem number 102, in that problem, this integral will arise at some stage. So that is the hint. We have done the proof. Keep a note, make a note of this identity. This is a very useful identity, especially in higher maths, in Fourier analysis. This will come in handy. And even now, sometimes in papers and all, and your AITS or test series and all, you will see integrals like this, sine of 5t by sine t and stuff like this. It will be really annoying to try to solve it in regular ways. It will be very easy to do it by this method, okay? I hope everybody has understood what I'm trying to say.
Yes, sir.
Yes, sir.
Okay, so that's all for now. Tomorrow's class, what we'll do is, one second, what are you saying? Can you show the previous question? What do you mean previous question? You can see the recording. Anyway, I'll share the recordings with you. You can see the video recording later, right?
Sir, I have a doubt. So what is the difference between definite and indefinite integration? Is there any method difference?
No, the difference is that definite integral is an actual area under the curve from some point to some point, right?
Okay.
You need to watch the videos in my channel. It is explained. So indefinite integral gives you an answer in terms of a class of functions. When you do indefinite integral, it is basically giving you the infinite number of functions which satisfy this, right? Something like this will come, right?
Yeah.
But definite integral is actually calculating the actual area under the function from x is equal to a to x is equal to b. So here the answer will come out to be a number, right?
Yes,
It is
sir.
actually going to give you an area. This is going to give you the possible functions, right? But the connection between the two is that you can do this by indefinite integrals also. You can say if fx dx indefinite integral was gx plus c, you evaluate it from a to b and you'll get g of b plus c minus g of a minus c. So you'll get basically g of b minus g of a, right?
Yeah.
So this is coming from the fundamental theorem of integral calculus. So you have to read that theorem, and from there we get a connection between definite and indefinite integrals. But remember, the definite integral is an area. Indefinite integral will get the answer in terms of a function, right? Anyway, we'll discuss more.
Sir, sir, you mean to say that indefinite integral gives a function which can basically calculate area from any two given points?
The function that comes as the answer to an indefinite integral, if you evaluate it between 2 points, you will get the area of that region.
Okay,
Right?
sir. Okay.
The answer, once after you evaluate, will be the definite integral, right?
Okay,
The
sir, got it.
link between the two comes from the fundamental theorem of calculus. You should go to Thomas and Finney. Thomas and Finney is a nice calculus book. You can refer to that. It is called Calculus and Analytic Geometry. In that chapter 5 or chapter 6, oh, maybe chapter 5. If you look at chapter 5 there and look at the fundamental theorem of calculus, the explanation is very nice. So this is one book that everyone should have. It will be useful for you even when you go to college. So it is a very good book. You should have the PDF of this book with you. And look at chapter 5 if you have a confusion about the fundamental meanings of the integrals. Okay. Fine. Anyway, we'll continue tomorrow's class. Tomorrow's class also will do problems, maybe some problems from the problem set. Otherwise, we'll continue with PYQs only. Okay. So,
Sir, you share your definite integration part, a playlist.
हाँ वो उसी playlist में है, ठीक है?
सर उसमें तो प्रॉब्लम सॉल्विंग था ना, मेरे को समझ में नहीं आया.
Calculus and analytic geometry, calculus and no, there is a playlist called From Calculus to Analysis, right? In that playlist, there are a lot of videos, and you will find definite integral videos also there. If you want more videos, you can search in the JEE Maths playlist. JEE Maths playlist में 192 videos are there, okay? And I'm sure there are 4 or 5 videos on definite integrals there. If you search definite integrals in my channel, you'll get 4, 5, 6 different videos, okay? So,
Okay, sir.
You will definitely find many videos are there. I will also find it and send it to you, but you can do that searching yourself, okay?
Okay, sir. Sir, and also that the PDF you sent was difficult.
It is difficult.
Yeah, I
So
was not.
if you are struggling a little bit, don't worry about it. Solve PYQs. If you are struggling with that PDF, don't worry about it. Solve PYQs, okay? Previous year's questions you solve first. The PDF
Okay.
is a little tough. That is, but sometimes you have certain questions which are tough in JEE Advanced, right? So ultimately, you have to prepare for that a little bit, but it is not necessary to do it at the beginning stage, okay? Like it's not assigned homework कि करना ही है PDF पूरा, ठीक है?
Okay, sir.
Sir, can you tell about CMI exam? Because I don't see many integral problems in that.
The CMI exam, I will talk to you separately, okay?
Okay, sir. Okay.
What we will do is, see, you have to focus on the number theory. I have told you about that in the basic video that I made, right? So in that video, follow the instructions in that video. We will go to the other topics also at some stage. Okay, so I will take some separate classes for you probably, because some portions of the thing will be different for you. Okay.
Okay, sir. Okay.
But if you see PYQs of CMI exam also, there are calculus questions. It may not be that complicated integrals, but it is conceptual and
Yes, sir.
nice questions are there. So you still have to learn
A
calculus
very
properly.
conceptual paper. I guess I have solved some previous year papers and they are very conceptual, not very tough,
Yeah.
but basic ideas.
So you have to try the PYQs, and from there we can see. We will discuss some of the CMI questions in our classes also. So
Okay, sir.
we'll see in the next class. Okay. Okay, fine. That's all for now. I'll see you next time tomorrow evening. Okay.
Thank you, sir.
Thank you, sir.
Bye.